The human eye is a marvel of nature, often compared to a sophisticated camera. This comparison isn't just poetic, it's rooted in the intricate mechanics of both systems. The eye, like a camera, is designed to capture and process light, transforming it into the images we perceive as vision. Both capture light and transform it into images we perceive as vision. The camera uses a lens to focus light onto a film or sensor, while the eye uses its own lens to focus light onto the retina. This process is fundamental to how we see and interpret the world around us. Imagine the eye as a camera, intricately designed to record the world around us. The cornea and lens of the eye work together to focus light, much like the lens of a camera. The iris, which controls the amount of light entering the eye, functions similarly to a camera's aperture. Light enters through a lens, just like in a camera. The pupil adjusts to control the amount of light, ensuring that the right amount reaches the retina. This dynamic adjustment is crucial for clear vision in varying lighting conditions. This lens focuses the light onto a sensitive surface at the back, similar to film in a camera. In the eye, this surface is the retina, which is lined with photoreceptor cells that convert light into electrical signals. These signals are then sent to the brain, where they are interpreted as images. This remarkable process allows us to experience the beauty and wonder of our surroundings. From the vibrant colors of a sunset to the intricate details of a flower, our eyes enable us to appreciate the world in all its splendor. The human eye, with its complex structure and function, truly is a window to the world. The human eye is protected by several outer layers. The cornea, a transparent dome, forms the front of the eye. It acts like a window, allowing light to enter. The sclera, the white part of the eye, provides structural support and protection. Covering the sclera and lining the inner eyelids is the conjunctiva, a thin, transparent membrane that keeps the eye moist. Light regulation is crucial for our vision. The human eye is a marvel of biological engineering, designed to adapt to varying light conditions seamlessly. The iris, the colored part of the eye, plays a vital role in this process. It acts like a camera shutter, controlling the amount of light that enters the eye. When you move from a dark room to a brightly lit area, the iris contracts, reducing the size of the pupil to limit the light intake. The pupil, which appears as a black hole in the center of the iris, is actually an opening that adjusts its size based on the intensity of light. This adjustment is crucial for protecting the inner structures of the eye and ensuring optimal vision. In bright light, the pupil constricts, becoming smaller to allow less light to enter. This helps prevent damage to the retina and reduces glare, making it easier to see in well-lit conditions. Conversely, in dim conditions, the pupil dilates or widens to gather more light. This dilation enhances our ability to see in low-light environments, such as during nighttime or in a darkened room. Behind the pupil lies the lens, a flexible, transparent structure that focuses incoming light onto the retina. The lens adjusts its shape to ensure that light rays are properly focused, allowing us to see objects clearly at various distances. This intricate coordination between the iris, pupil, and lens is what enables us to experience the world in vivid detail. Section 4. The retina's light processing powerhouse. Macula and fovea. The retina, the light-sensitive layer at the back of the eye, plays a critical role in vision. It's here that light is converted into electrical signals. The macula, a small specialized area within the retina, provides sharp central vision. At the center of the macula lies the fovea, responsible for our most detailed vision. Section 5. The optic nerve, a high-speed data highway to the brain. The optic nerve is a vital link between the eye and the brain. It serves as the primary conduit for visual information, ensuring that what we see is rapidly and accurately transmitted to the brain for interpretation. Without this crucial connection, our ability to perceive the world around us would be severely compromised. It transmits the electrical signals generated by the retina to the brain for processing. These signals are the result of light hitting the photoreceptor cells in the retina, which then convert the light into electrical impulses. These impulses travel along the optic nerve, making their way to the brain, where they are decoded into the images we see. Imagine the optic nerve as a high-speed data cable, carrying vast amounts of visual information. Just like a fiber optic cable transmits data at incredible speeds, the optic nerve ensures that the visual data is delivered to the brain almost instantaneously. This rapid transmission is essential for our ability to react to our environment in real time. This information travels from the eye to the visual cortex at the back of the brain. The visual cortex is the part of the brain responsible for processing visual information. It interprets the data received from the optic nerve, allowing us to understand and interact with the world around us. The efficiency and speed of this process are what enable us to see and respond to visual stimuli almost instantaneously. Section 6. The brain's visual symphony creating the world we see. The brain is the final destination in our journey of vision. It receives the electrical signals from the optic nerve and interprets them, creating the images we perceive. This complex process involves various areas of the brain working together to decode color, shape, depth, and motion. The result is the seamless and vibrant world we see around us.